In this lesson, I'll show you how to find the tangent to polar curves. The question reads, find the points on the curve r squared is equal to sine 2 theta, where the tangent line is horizontal. Now the reason why this is important is because by knowing this, we can avoid the process of converting from polar equations to rectangular Cartesian equations when seeking information about the tangent. So what we want to do is find the derivative of this function and then set dy over d theta equal to 0 and find out all the theta values. Once we find all the theta values, we can substitute them back into the original equation. If you're confused by that, let's start by implicitly differentiating this equation. Starting on the left side, we have r squared. I'll use the power rule. We end up with 2r dr over d theta. We're deriving this with respect to theta. And on the right side, the derivative of sine is cosine. So we have cosine 2 theta, and the derivative of 2 theta is 2. Solving for dr over d theta, because we need that, and I'll explain why in a moment, we end up with both sides being divided by 2r. This 2 and this 2 cancel out, and on the right side we have 1 over r cosine 2 theta, and that's equal to dr of d theta. This is important because if you take a look at this equation here, we're told that the derivative of a polar equation converted into Cartesian equation is equal to everything on the right side here. And if we're looking for the tangent line that's horizontal, we need to set dy over d theta equal to 0. So all of this needs to be set equal to 0. Now notice what we found here. We found dr over d theta, so I will replace what I found here right into that expression and then set all of that equal to 0. So what we're looking for is dy over d theta is equal to 0, and we can do that by substituting this expression into there. 1 over r cosine 2 theta times sine theta plus r cosine theta. That is being set to 0. To find out what theta is, and this is where the hard part starts, or the fun part if you want, is you'll need to convert wherever you see a cosine into sine, or vice versa, wherever you see a sine into cosine, and then have an equation that's exclusively in sine or cosine. You don't want both. And we can do that by using identities. So you'll need to know your identities for this. But first, I'll factor out 1 over r, and look what happens if you do that. 1 over r, this becomes cosine 2 theta, sine theta. That becomes r squared cosine theta is equal to 0. And if I set 1 over r equal to 0, that doesn't work. No value of r can get you equal to 0 on the right side. So we'll just ignore that, and we'll only focus on this factor. So just to understand what I did, we're only going to focus on this factor equal to 0 because that can never equal to 0. Now, recall that there are identities known as the cosine of twice an angle and sine as twice an angle identities, or double angle identities, in other words. Cosine 2 theta is the exact same thing as 1 minus 2 sine squared theta. So I'm going to replace that factor with 1 minus 2 sine squared theta times sine theta plus, and remember, r squared is equal to sine 2 theta. So I'm going to replace this factor with sine 2 theta, our original equation, multiplied to cosine theta. I'll expand the left side, so I'll take the sine theta, multiply it to these two terms. At this point, I can change sine 2 theta using this identity to 2 sine theta cosine theta, and remember that's equal to 0. So I'm going to change this factor into 2 sine theta cos theta. 2 sine theta cosine theta, that's gone, cosine theta. And there's a reason why I'm doing this, because now we have cosine squared theta. Cosine squared theta, this part, is equal to, remember the Pythagorean identity, where we have sine squared theta plus cosine squared of theta is equal to 1. If I bring over sine squared theta, I have 1 minus sine squared theta. So I'm going to replace this with 1 minus sine squared theta, and now we have an equation that is exclusively in terms of sine. I'll now multiply or expand this 2 sine theta into this binomial. So I have sine theta minus 2 sine cubed theta plus 2 sine theta minus 2 sine cubed theta. And now we can collect like terms. Notice that this term and this term are alike, and these two terms are alike. So we have 3 sine theta minus 4 sine to the power of 3 theta is equal to 0. Factoring out a sine, bracket 3 minus 4 sine squared theta is equal to 0. This factor sine theta is equal to 0. Remember, sine equals to 0 when theta is equal to 0 and when theta is equal to pi. So we have two x coordinates so far, which we will substitute back into the original equation momentarily, not right now. And now we'll set 3 minus 4 sine squared theta equal to 0. We'll take that 3 over. That becomes negative 3 minus 4 sine squared theta. Divide both sides by negative 4. We have 3 over 4. Square rooting both sides gives us sine theta is equal to the square root of 3 over 4. And remember, this is the same thing as saying the square root of 3 over 2, plus minus. Therefore, we can use special triangles to help us figure out theta. It turns out that if you find out what theta is using special triangles, theta is equal to pi over 3. And sine is positive here, and sine is negative here and here. So from here to here is pi over 3. From here to here, that's pi minus pi over 3. And over here is pi plus pi over 3, which is equal to 4 pi over 3. And from here to here, we have 2 pi minus pi over 3. What you're supposed to do, now that we have more x coordinates, is substitute all of these values, pi over 3, pi minus pi over 3 is equal to 2 pi over 3. Substitute, and remember, these are all y coordinates that we're looking for eventually. We have 4 pi over 3, and 2 pi minus pi over 3 is 5 pi over 3. So it turns out that if you substitute 0 into your original equation, r squared is equal to sine 2 theta, you should end up with 0. Substituting pi over 3 should give you the fourth root of 3 over 4. In addition, given that we have r squared, you would have gotten a negative version of this. So pi over 3 negative the fourth root of 3 over 4. Substituting these two will not give you an output. So we can ignore those. And substituting 4 pi over 3, you'll end up with two outputs, and they are the same as these. These points are when the tangent is horizontal to the x-axis, or the polar axis. And there you have it. That is how to find the tangent to polar curves.